Software Project 3 Simulations for a Fireplace TV stand. The members of this group are Orlando Fernandez and the one who talks, Reynel Castaneda. Introduction. We decided to do a wood fireplace TV stand for our project and do different studies to it. After some research and tries, the material picked was balsa, which is a kind of wood that designers are increasingly turning as a material for furniture. Lauding is its sustainability as a fast-growing tree, along with its aesthetic properties, and also 2024 alloy was used to make the fireplace. The studies that were applied to the stand were static study. The objective is to know if the stand can handle a TV and the different accessories placed on top, like a gaming console, cable provider, and all this without yielding. Also the thermal study, which the purpose is to know if the stand can support the heat transmitted from the different devices and the fireplace. Also we made a buckling study, which is to know the critical load that the stand can support without collapsing, and a frequency study to analyze the natural frequency of the stand. Then we have the parts. To the left we have the bottom part, which is like the principal structure of our assembly. We have the top shelf, which is the one that is going to have the TV and the gaming console, and the fireplace, which is the one that is going to be heating.
The first study we performed was a static study, where we fixed the bottom face of the assembly to the floor, basically, and used 3 different loads to perform the static study. One is a 70-pound load, which represents the TV weight on the top shelf. Then we use a 10-pound load to represent a gaming console resting on the top shelf as well, and an 8-pound load on the second shelf, which represents a cable receiver, basically. So using a standard mesh, we performed the static study and we get the results that we see in this slide. And it was a pretty successful simulation because the factor of safety was way above 1, an 82.07, which means the part is really solid and it's not likely to fail with these loads and can basically sustain bigger loads as it is right now. The second study we performed was a thermal study, in which we used a transient state with a runtime of 180 seconds, using 60 seconds time steps. The initial temperature was 200 kelvins, and we placed 3 different heat sources. The first one was the 2000 watts from the fireplace, 60 watts from the gaming console, and 8.5 watt from the cable provider. This data, we did a research online where we got this pretty accurate data for the heat dissipated by these devices. And then we also did a research to find the heat convection coefficients for the different materials and the emissivity as well for the different materials. Using a standard mesh, we performed the thermal study and we run it for the whole 180 seconds, and we got the temperatures at 3 different states, at 60 seconds, 120, and 180 seconds. And we could observe how the maximum temperature was increasing as the time passed by, which is logic, makes sense. And we also can see on the figure on the heat map how the different parts of the assembly are affected by the heat dissipated by these devices. Another study we performed was a buckling study, in which we used similar fixture and loads to the static study and a standard mesh too. After performing this study, we got the load factors and amplitude of the first 2 modes, and we could see by the load factors on the first 2 modes, which are really high load factors, 166 and 281.93, that the critical load for this assembly, it's really high, which means the part is pretty safe and will not buckle under the current load. The frequency study that we performed was a simple study using the bottom face fixed to the floor to analyze the nature frequency of the part without any loads applied. And we got the first 4 modes frequencies just to get more data and a deeper analysis of the part. The different frequencies are represented on this slide. As we can see, they keep increasing mode after mode.
Alright, in conclusions, we can say that this project was a success since the Fireplace TVS-10 passed all the studies successfully. The stand is super secure since it has a factor of safety bigger than 1, as well as the load of factors, so we can confirm that the stand will not break or collapse. And thanks to the thermal study, we know that it would not get overheated. We think that we did the most essential study for our case, and we highly recommend this study for any similar furniture or with similar functions. As a part of the optimization design, we tried different materials like stainless steel, alloy 2024 for the whole assembly, and even though they had stronger properties, they had higher density, what made the assembly way too heavy, over 4,000 pounds, almost impossible to transport. Thank you.